Hallo allemaal, met deze even een demonstratie van mijn nieuwe inverse kinematics algoritme. In English, hello everyone, welcome back to this video. Today I'm going to show you my current just testing inverse kinematics algorithm called LookIK. And this is what you currently are seeing is the program actually working. As you can see, the inverse kinematics algorithm currently is getting random points where it is solving towards. This is currently a 10 degrees of freedom arm, if I remember properly. 8 middle joints, 1 start joint, which does the rotation, etc. And actually, I don't call them joints, I call them bone vectors, since they're basically just vectors, which are based upon each other. But yeah, this algorithm just gets a random point and it moves towards it. And yes, this is not full speed, otherwise I wouldn't make a video about it. This algorithm is actually quite simple. It's just a really, it's not, doesn't even have the Jacobian or all kinds of fancy stuff. It's just a simple heuristic inverse kinematics algorithm, and it just reduces the error, and it's good at it. Also, I am changing the learning rate based on the error. So the learning rate is the error divided by 100, which actually gave it this huge performance boost. So yeah, let's increase it and show you what it can do. Okay, this looks more like it. Do you think this is the limit? Definitely not. Okay, so here, now it's going like this. And now it's going like this. We can go even faster, like this. And you know, it is actually blocking. The render loop is actually being blocked by the inverse kinematics algorithm. As you can see, we can still even move smoothly through the scene, which is like insane, right? And you're probably wondering, okay, so that's pretty cool. So what kind of algorithm are you actually using for this? And it's quite simple. Let me actually just grab my code editor, right? So the algorithm is really simple. This is just the GL visualization. It's messy code, I know, I don't really like it. And we're using a method right here which just calculates, I got this from Wikipedia, I didn't want to derive this myself. But just basically you give it an axis and you give it a rotation, and it generates a rotation matrix around the axis. That seemed a bit more cool to me than something else. What we also have is a Radian function. So the input here is degrees, and a units function which we use to generate units. But the real magic is actually the bone, which as you can see is quite simple. We have two types of bone. We have twisting and rotational joints in this case, or we're twisting and rotational bones, which are actually joints, but I joined them together in so-called bone vector. And these are all together in the chain with next elements, and we have some caching inside of it for the matrices to prevent some extra computations which are not required. And then we have the forward kinematics, which is really simple. We just go from the last joint to the start joint and constantly just add the vectors onto each other and transform them. So that's how we reach the end vector position. And this is the inverse kinematics algorithm. It's really simple. We just loop to the max iterations. We loop over all the bones. We start tweaking the value and checking if the error increases or decreases or increases in both situations. In this case, we set the eta to a positive and a negative, and we check which one is actually giving us a better solution, right? So that works fine, and then we just check if the error is less than epsilon. If less than epsilon, we just return the error, since we've actually reached the desired position. And if not, we tweak the eta, the learning rate, based on the current error, which will speed up the algorithm. That's quite funny. If I don't do this, it will go really slow. So I know this is not really solid or something. It doesn't have evidence why this works or something. In reality, it just works. And then of course you have the simple visualization, which is just some by OpenGL. Not modern OpenGL, didn't want to work with that. And we have some bones right here, some key processing, some basic camera, and that kind of stuff. But it works pretty neat, and I just want to show that to everyone. Well, thanks for watching, and see you later.